Once again, we have a equilibrium problem where we're given a equilibrium constant, and now we're looking for the solubility in terms of molarity. So you just need to know what is what as far as the terms go. It's just another equilibrium constant problem. The solubility in terms of molarity, that, remember, will be our X, which is an equilibrium concentration when we set up our rice table. And then, of course, this is just it's like our Kc, or equilibrium constant. So the first thing let's do is set up a rice table. So for this is solubility, so we're just going to make our reactant is just the solid, and it will be breaking into its two ions. Remember, we need to watch coefficients. They play a role in so many parts of this. So that's our reaction, is just the solid dissolving. And then for initial, remember, we pretend like we're starting with just the solid and we have no ions. So like before we put it in the water, the change, we always use X for this. We're going to say X is the amount that dissolves. And then we use the coefficients. We are always on this step, we use the coefficients here to get the number of X. And so that's why it's just minus 1X there. But so here it'll be plus X. And for the fluoride, it will be plus 2X. Okay, and then at equilibrium, and this is where we're adding the 2 from above, we're going to have solid minus X, X, and 2X. Okay, and these are our equilibrium concentrations, or equilibrium amounts. Okay, so after we set up our rice table, let's set up our equilibrium constant expression. In other words, for this reaction, what is KSP? And I put that there. Remember, it's products over reactants, but actually we don't include the reactants because the reactant is a solid. So we just go by this reaction and we do the products. Remember that we use the coefficients to get exponents, so we need a 2 there for the fluoride, I should say, of X. So the calcium and the fluoride. Well, we have our solubility product here. And what we're solving for, the molar solubility, is we're solving for X. So let's plug this number in. Let's go ahead and do one more step. Before we do a cubed root, so to get rid of the x to the third, the power of 3, we'll take a cubed root of both sides. And that can be done on your calculator. You might have to look for it if you don't know already. And again, when we get to x, that is our molar solubility